Now, my student, let us proceed with today's lesson, and we are proceeding with wave description, and today we are going to look about the term wavelengths. Today we are going to look the term wavelengths. Wavelengths can be defined in a different ways, many different ways, but the fundamental definition of wavelengths is saying wavelength is the distance between any two successive points which are moving in the same direction and which are at the same distance along the equilibrium or from equilibrium position. Wavelength is the distance between any two successive points of which nature, which are moving in the same direction and which are at the same distance from the equilibrium position. Now, for you to understand what does wavelength mean, let us consider this illustration here. If you consider this illustration, I'm going to show you what is wavelength. Remember, we are using the transverse wave shape. Now, do you see, we want to define wavelength. We said there must be two consecutive points which are in the same directions, but also which are in the same distance from equilibrium positions. Now look this one. This point here is what we call, this point which is 0 is what we call equilibrium position. Oh, this line represent equilibrium positions. Now for you to know, for you to get wavelengths, the graph of displacement against distance must be drawn. Make sure for you to calculate wavelengths, the x-axis should be contains the distance, which is measured in meter. Distance in what? In meter. Distance which is measured in meter. Now let us go back now to our illustration. Do you see this point? Do you see this point here and this point here? Yes. How are they related? These points are two consecutive points because after this point, the next point is this one, which have the same characteristics. Therefore, this is the first point, this is the second point. Therefore, these are 2 points. But again, are they have the same distance from equilibrium positions? Yes. From this point to this point is the same. From equilibrium to this point is the same. Another question. The particles are moving in the same direction in this point? Yes. Both of them, their particles are moving up. The particles at this point are moving up. Now, what is the distance from these 2 points? The name given to the distance between 2 consecutive points whose direction is the same, whose distance from equilibrium position is the same, is called wavelength. Therefore, from this point to this point is wavelength. Why? Because these 2 points have the same, their particles are in the same directions. Not only that, the distance from equilibrium position between these 2 points is the same, but the best among all, these 2 points are consecutive points. Okay, go. Let us look again here. Do you see this point here? Yes. Do you see this point here? Yes. How are they relating? They are consecutive points because after the first trough, which is this one, the second trough, this is this one. Therefore, this point and this point are consecutive points. Are they have the same distance from equilibrium position? Look, from this point to this point is the same as from this point to this point. From this point to equilibrium is the same as from this point to equilibrium. Yes. Look, The particles, are they moving in the same direction? Yes, the particles at this point and at this point are moving the same direction because both of them, they are moving downward. Therefore, what is the distance between point 1 and 2? The name given to the distance between point 1 and 2 is wavelength. Another point. Look this point here. I want to give you, apart from this, look this point here. Do you see this point here? Yes. And another point. Do you see this point here? Yes. What can I say? The point, this point here, and this point here, are they related? Yes. The distance from this point here, let us call it point 1, and this call it point 2. The distance from this point to equilibrium is the same as the distance from this point to equilibrium. But are they consecutive? Yes. Why? Because both of them, they are moving in the same direction. They are going downward. We cannot say this one and this one are consecutive point. Why? Because this is going downward, but this is going upward. Therefore, this point and this point are not. But this point is consecutive with this point because they are moving in the same direction, but also they are at the same distance from equilibrium. Therefore, what is the name given to the distance between point 1 and 2 here? The name is called wavelength. That's okay. Now, do you see this point here again? Yes. And this point here? Yes. Why? Particle at this point, they are moving up. But also, particle at this point, they are going up. But the distance from them to equilibrium is the same because they are at the equilibrium position. Now, what is the name given to the distance from this point here to this point here? The name given to the distance is wavelength. Is what? Wavelength. Therefore, following this illustration, you can try to treat wavelength the way you want. That is just by following what is wavelength is. Wavelength is the distance between any two successive points which are moving in the same direction and which are at the same distance along the equilibrium or from the equilibrium position. That is wavelength. And this is the illustration. But after this illustration, you can understand that we have now other definitions of wavelengths. Now, do you see from this point to this point, from this point here to this point, the distance is wavelength. But from this point to this point, there is a complete cycle. This because this is a half of the cycle and this is a half of the cycle. Now, we can define again wavelengths at the distance between one complete cycle, because from this point to this point is a complete cycle. Now, the distance between a complete cycle, we call it a what? Wavelength. That's one. But do you see this point here? Yes. We can also again define wavelengths at the distance traveled by a wave just before repeating its oscillation. Look at this point here, call it maybe point A. The wave is repeating its oscillation because it is going to form again a crest. After forming crest here, it forms trough. Therefore, it goes again to crest. That means it now starting to repeat its oscillation. Now, the distance covered by a wave just before starting its oscillations, just before repeating its oscillation, is called wavelength. That is not only the definition of wavelength. Do you see again from this point to this point here? Yes. Do you remember this point? From this point, the time taken for a complete cycle is called what? I think you remember. It is called time period. It is called what? Time period T. Therefore, the distance traveled by a wave in a time period. The distance traveled by a wave in a time period is called wavelength. It's called what? Wavelength. No, that cannot be only wavelength. Do you see these 2 points here? Yes, these points we call them crest. Therefore, the distance between 2 consecutive crests is called what? Wavelength. All these definitions, they come from the first definition, which is the fundamental definition of wavelength. Again, do you see this point here? Yes. This point are called trough. Therefore, the distance between 2 adjacent trough is called what? Wavelength. That is another definition. Therefore, when we sum up the definition of crest and the definition of trough, we come up with a single definition of another definition of wavelength, which is saying wavelength is the distance between 2 consecutive. Before going there, do you remember the case of compression and their functions? Compression is this way. Compression this way. Now compression is represented by crest. Their function is represented by trough. Compression here again. Compression. And again here we can start with layer function. Here. Now the distance between 2 consecutive, this is crest, compression. Layer function. The distance between 2 consecutive compression in a longitudinal wave, 2 consecutive compression in a longitudinal wave, we call it wavelength. The distance between 2 consecutive layer functions also, we call it wavelength. Therefore, this is how we can also define wavelength according to longitudinal waves. Now, from the idea of crest and trough and the compression and layer function, we can comment that wavelength is the distance between 2 consecutive points, 2 consecutive similar points. For example, this one and this one, crest and crest, these are 2 consecutive similar because both of them are crest. Therefore, the distance between them is wavelength. This and this are trough. Therefore, these are 2 consecutive points which are similar. The distance between them is called wavelength. Therefore, this is how we can define wavelengths. Therefore, it is now for you to choose which one will be a very good definition for you. Have a short break. We're going to see each other very soon.